Okay. Good afternoon, all my dear students. All this case with my screen. It's fine. Okay. Dear all students, welcome for the today's lecture. Good afternoon, everyone. Is it? Am I audible? And my screen is visible to everyone?
Yes, sir.
Okay, thank you. Dear students, yesterday actually I announced that there is a conduction of test, class test. Actually, tomorrow I will take one more extra session for your test. So for that, because today is only 1 hour I got for the lecture. So today we will continue with the lecture, and tomorrow means it is Thursday, right? So Thursday you have a lab sessions. So in the lab sessions, I have lab session at 11 o'clock. Please all of you join at exactly 11 o'clock to my lab session. And one more lab session of any other stops, any other subject lab session. I will conduct your test, microprocessor test on first unit and second unit. We have to conduct first unit and second unit. We have to conduct MCQ questions test. Okay. So just I will announce you all of you be ready for the test tomorrow. Tomorrow at any session I have to conduct at any session. So please all of you be ready. Okay. So this is the announcement, kind announcement from my side. And today we will continue with the lecturing class theory part because only 1 hour we got today, 3:30 to 4:30. Okay. So and also dear students, today we will up to last lectures we have to cover 3 units. Okay, just a minute, I will open uh, okay, I will open the syllabus copy here. So okay, this is the syllabus copy for your batch. So that is control F. Okay, so this is syllabus copy, dear all students. So first unit completely we have to cover, and second unit we have to cover, and all the instructions of third unit also we have to cover up to the directives and all the 8086 instructions. So dear all students, totally we have to cover this much syllabus. So today we will move to the fourth unit, that is system bus architecture. That is system bus architecture. It means that in the bus architecture there are two main types, that is minimum mode and maximum mode. In the basic of 8086 configuration, that introduction with the basic introduction side, basic 8086 configurations already we studied in the unit number 2. Okay, so here in this bus architecture we will just study minimum mode configuration and maximum mode configuration and system bus timing, minimum mode, maximum mode, and also the difference between minimum mode and the maximum mode we have to study in the unit number 4. So this unit number 4 is one of the smallest unit in among of all other units. Whatever totally 8 units are there for your syllabus, only this fourth unit is very small unit, only 4 hours and only two topics, minimum mode and maximum mode, and one more system bus, that is only 10 to 15 minutes explanations, more than enough. So one class for minimum mode and one more class for maximum mode and system bus. Only within 2 lectures, I have to complete this unit number 4 because it is very small unit. And directly questions are coming like what are the minimum mode configuration and what are the maximum mode configuration. Along with that, how much the time is needed to execute the buses, that is system bus timing. Okay, so now I will go through this init, that is init number 4. From the today onwards we will study with unit number 4, that is system bus architecture as per your prescribed syllabus from the university. And in that we will go through minimum mode. Introduction of 8086 you studied, that data bus, control bus already you studied, right? And 8086 configurations also you studied. So now I will go to the minimum mode configuration today's lecture, and tomorrow's lecture or it may be a next lecture I will go to the maximum mode configuration. Minimum mode and maximum mode, these are the basic 8086 configurations, minimum and maximum. Okay, so come to the my notes here. So this is the notes I prepared for you. So these notes already I saved with you, I think, right? So in the microprocessor I saved with you. Okay, okay, I'll check it. I don't shared.
No, sir, not shared.
Okay. Now I will say it. Fine. uh so I think everyone has got these notes in the microprocessor group.
Yes, sir.
Yes, sir.
Okay, you go through it. Very easy, very only 15 to 6. Only 12 pages are there. Remaining 4 pages I make you do for the questions. Only 12 pages of this entire unit. Very small unit. Only 2 topics, minimum mode, maximum mode. That is nothing but a basic of 8086 configurations. Only 2 topics, more than enough. Okay. Okay, just a second, dear students. Just a second. Okay. Yes. Okay. Fine. Today we have to start with our fourth unit, microprocessor fourth unit, system bus architecture. In that basic configurations we have to study. What are those basic configuration? One is 8086 minimum mode configuration, and the one more is 8086 maximum mode configuration. There are 2 types of 8086 configuration. So here, dear all students, in the minimum mode configurations, we have to use it. So and one more thing, at the beginning or it may be in the explanation of first unit, some of them they are asking the questions about clock generator. What is a clock generator and what is the clocks we have to use it? So that clock and clock generator I have to explain it in this unit. In the unit number 4 I have to explain all the clock generators and concept of clocks. Please, who are asking question that time, you have to more concentrate. Almost all of you more concentrate on this clock generator. Okay. So that time I said you. It comes in the unit number 4. That time I will explain you. So that's what I remembered you who are asking clock generator. I think 3 to 4 students are asking that questions. What is clock generator? Clock generator. So that time only short 1 or 2 lines I have to explain. But in detail, this unit I have to explain you in the configuration of 8086. In the configuration of 8086, that clock generator is so much used here. Okay. So, dear all students, here for the minimum mode configuration, we have to write like this: minimum bar max, sorry, minimum slash max bar. It means that minimum is active, maximum is not active. Minimum is active and maximum is not active. So that's what we say it is a minimum mode configuration. That is minimum mode configuration. So here in this minimum mode of 8086 is only the processor in the system. So it is having the 8086 the processor, and the minimum mode, this is the circuit diagram. This is the architecture or whatever you say circuit diagram of. So I will make it as demise. Okay, I think this entire thing is visible. Yes, fine. So this is the circuit diagram of minimum mode configuration. So dear all students, you have to observe this one. I am using 4 chips. Four chips. Yes, 4 chips. First chip name is 8086 microprocessor. This entire chip, and this entire chip, all the configurations.
Sir, you are not audible.
Hello, yes, students, am I audible?
Yes, sir.
Okay, okay. So here, dear all students, in this I have to use the 4 microprocessor chips. One is by default 8086, because whatever we are going to study, all the configurations, that is with 8086 only we have to study. So in the 8086, whatever 40 pins you have to use it, no? In the first unit and second unit, you have to study it, all the pin configurations. So these are the pin configurations we have to use it in the architecture of 8086. Whatever we are using, ALU we are using, again it is repeating same thing. And address data lines we are using AD0 to AD15, and also the address lines, data lines. Sorry, these are the 0 to 15 data lines, and that 16 to 19 address lines we have to use it. And bus high enable, that is BHE we are using, and that DT data read we are using, DEN we are using, and this one NMI non-maskable interrupts. Interrupts we have to use it, interrupt acknowledgement we have to use it, hold we use it, and hold acknowledgements we have to use it, HLDA, and memory and input output we have to use it, read we have to use it, write we have to use it, and this is only the one extra here, that is minimum and maximum mode to the PCC. Only this one pin is extra. Remaining all are you studied right in the architecture of 8086. So So same things, it is repetition. Along with that, along with 8086, three more extra chips we have to use it. One is 8282, the chips 8282. Basic is 8086. Everything we are going to manipulate with the 8086 only. So in that we have to connected 8282 one microchip and 8284 one more microchip and 8286 one more microchip. So these three chips we have to use it along with the 8086 microprocessor. This is entire circuit diagram of minimum mode configuration. So if questions is asking, you have to draw entire this architecture or diagram. After that, you have to explain 8086, 808, sorry, 8282 and 8284 and 8286. All these four chips you have to explain. So now I will explain one by one. Please, we will all of you carefully concentrate on this. So here the 8284 we have to use it for clock generator only. For the clock generator, we are using 8284. In that clock generator, we have to use X1 and X2. In the architecture of 8085, X1 and X2 you have to use it for clock generator. That is two pin configuration. I told you clock generator we are using at X1 and X2, and this and this I am explaining this 8284 clock generator with the X1 and X2 pin numbers. So in this clock generator we are using set and reset, that is reset circuit. Set and reset we have to use it for the clock. And ready state, that is system is in the ready state to execute, that is ready state we have to use it. And in the 8284, that clock we are going to connect it with the 8086, and that set and reset and also ready the system we are going to connect it with 8086. This set and reset and ready and the clock is done by with the 8284. So now we will go with this explanation. In the clock is provided by the 8284 clock generator. That is clock generator is nothing but, that is 8284 is a clock generator integrated circuit. IC is in the sense integrated circuit, and it provides clock signal as a series of pulses at a constant frequency. So what the clock signal is do? It will send the frequency in constantly. There is no variation. It's a kind of regulations. So all of you have to use the regulator to the fan, right? In a home appliances for the fan, you are using a regulator. So what regulator will do? The constant flow of current is maintaining. Like that, in the clock generator, the main function of clock generator is the series pulses at a constant frequency to the entire circuit. Constant frequency it will supply. That purpose we have to use the clock generator. And also it synchronizes the ready signal which indicates, that is ready signal. This is the ready signal which indicates that in the interface is ready for the data. So what it will do? For the data is going to be ready for the interface. That one is indicated by ready signal, and also synchronizes the reset. One more is reset signal, which can use to initialize the system. Which can use to initialize the system. That is for the reset. And there are two ways for providing the frequency to the input to 8284. For this, there are two ways to giving an input clock. The first one is through the EFI. The EFI in the sense external frequency input, and the second one is through the oscillator clock inputs. So these two are different options for to giving a clock generator to the 8086 from 8084 IC chip. That is through EFI or through oscillator clock inputs. So what is EFI? That is external frequency input, which is a pulse generator circuit can be generated to the external frequency input pin to provide an external frequency. This one we have to say external pin input, that is EFI, external frequency input. And same way we have to use two pins, that is X1 and X2 at the above. So those are oscillator clock inputs, and oscillator can be connected across the X1 and X2 pins or lines to provide a constant clock signal. Only the main aim of clock generator is we have to supply, we have to given constant frequency signals to the 8086. Why we need to maintain the regulations in the 8086 microprocessor? We have to use clock generator. In both the cases, the output clock frequency is equal to the 1/3 of the input clock frequency. Output clock frequency is 1/3 of the input clock frequency to the procedure. So 1/3 is in the sense of how much percentage? That is 33% of duty cycle is required by the microprocessor. Duty cycle means what? It is going to be the time is needed for execution of particular task in the oscillators. From the oscillator, that is 1/3. It means that 33%, 33.333 something you will get it. That is 33% duty cycle is required for the microprocessor. So in this clock selection, so that is for the clock generator, you have to use F bar, F slash C bar is 1. It indicates that how you are going to use the different flags. Like that, you have to use F slash C bar is 1 or F slash C bar is 0. If it is 1, the input clock is given through the external frequency input. If it is 0, then it is given by the oscillator inputs, either X1 or X2. So 0 is for oscillator frequency and 1 is for external frequency input. Okay, so these two different conditions we have to use it in clock generator. I think I am clear to your questions who are asking the question at the beginning, first in it. Okay, so and next, regarding the addresses, from the address bus is latched into a 8 to 82 bit latch. So in that, as 20-bit address bus is always 20 bits, and 8086 is a 16 bit. For that, we have to use the offset address for 4 bit. That is 16 plus 4 is 20 bits to manipulating an address. So here, the 20-bit address bus, that is 3 such latches are required. That is ALE of 8086 is connected to the stop byte of a latch, STB of a latch we are going to be connected. So now I'm going to, this is about the clock generator. Now I'm going to explaining about 8284 microchip. That is 8284 micro, sorry. This is all about 8284 microchip. The 8284 microchip is used for clock generator. In that there are two types, external frequency input and oscillator frequency input. So that F slash C bar is equal to 1. That time we are going to be use EFI, and F slash C bar is equal to 0. That time we are going to be oscillator, used oscillator. Okay. So this is all about clock generator. Next, I will move to latch. So this one is latch. 8282 we have to use it for 8-bit latch. Next, I am going to explain 8282. So 8086 is already everyone is knows. Just you have to study it, and 8284 now I have to explain it, and 8282 now we are going to explanation of 8282. So here in the 8282 is used for 8 bits. That's what we call it as octal latch. Octal means what? 8 bits. So in the 8 to 8 bits is an 8-bit latch, and in the 8086 the address bus is multiplexed with the data bus and the status bits, and also the 8282 is used to latch the address from this bus, and also that algebraic and logical enable signals is connected ALE is connected to the STB, this one, that is to the STB, and that STB to the A2 to A to the H. So here when STB, that is ALE, is high, the input is latched and transferred to the output, hence address is latched. When STB is low, when it is low, in that the input is discarded and data is not entered into the latch. So there are the two conditions, high condition and the low condition. If high condition, data transfer is happened. If low condition, then no entered the data into the latch, hence the address is remains in the latch. So for that, we have to use these two, high and low. And so in this, the data bus is driven through the 8286 8 bits transceiver. Two transceivers are needed for the 16-bit data bus. So here this is for the latch purpose, we are using 8 to 8, that is with the 20 address lines, that is from A0 to A19. Totally 20 address buses we are going to be used in the 8 to 8 latch with the bus high enable. Bus high enable is equal to 0. Bar is in the sense it is 0. So this is all about 8282. And next I will move to this one, that is 8286. That is fourth chip. First chip is 8086. Second chip is 8284. Third one is 8282. And now this is fourth one, that is 8286 microchip we are used. So for this 8286, it is used for data transceiver, data transmitter as well as receiver. Transmitter as well as receiver, for that, for transmitter 8 bits and the receiver 8 bits, totally 16 bits we have to use it. That is in the mode of 8-bit transceiver acts as bidirectional buffer. 8-bit bidirectional in the sense what? One side 8 bit and reverse side 8 bit, totally 16 bit. It is enabled with, that is oscillator enable with the low, that oscillator enable is low. So in that we have to use the T controls directions of data. So that T means what? T is used for time. If T equal to 1, data is transmitted. If T equal to 0, data is received. So for the T equal to 0 is received and T equal to 1 is data is transmitted. So for the transmitted is 8 bits and received is 8 bit. Totally 16 bits we have to use it for 8286. And also in the transistor are enabled through the DEN signal, while the directions of data is controlled by DT bar R, means the data transmitter or receiver signals with 8086. So that data enable is connected to the oscillator enable, and that data and receiver DT slash what? That is a data transmitter as well as receiver is connected to T, is connected to T in this. So this is the T bit. It is a oscillator enable, and which that oscillator enable is connected to data enable, and the T is connected to either data transmitter or data receiver. So totally it is a 8-bit transmitter. Because of bidirectionals, 8-bit plus 8-bit, that is a 16-bit total in the 8 to 86. So this is entire the explanation of 8086 minimum mode configurations. In the minimum mode configuration, so we have to use 8284 for a clock generator, 8282 for latch, and 8286 is for transmitter as well as the receiver. So in the theory part, you have to explain everything about the 8086 and clock generator in 4 to 5 lines, and 8282 you have to explain in 4 to 5 lines, that is the latch, and 8286, that's a transceiver, we have to explain 4 to 5 lines. So entire 20 to 25 lines you have to explain this entire minimum mode configurations of 8086. Very easiest concept. Just you have to study about these three microprocessor chips, that is 86, 8282, 8284, 8286. Okay. So this entire explanations also I will have to given clearly. Please all of you go through it. This is about our internal, minimum mode configurations of 8086. So that data enable and transmitter receiver have to make it as a one table. If it is one and there is no receiver or transmitter, then trans receiver is disabled because of no transmitter as well as no receiver. If both are zero, enable and transmitter receiver both are zero, then the data is received. If it is enable is zero and transmitter is one, the transmitter the data. This is the truth table for T transmitter E82 86. So here also same thing that uh, memory input and output, memory read and memory write. That is action. If one, this is 101, then the memory is read. 110, memory is write. If 001, it is input output read, and if it is 010, that is input and output write. So here that memory, input and output, and the read and the write, entire this table are decoded by the 3 to 8 decoder. So for that, one more chip we have to use it, that is integrated circuit IC of 74138. So actually this is for not your syllabus, just for the truth table purpose I am explaining you. And data memory access, dynamic memory access is also handled using this hold and hold acknowledgement signals and the interrupt acknowledgements. Interrupt acknowledgements also we have to use it with the acknowledgement by 8086 as a response to uh, INTR, that is interrupts. Okay. So dear all friends, this is just about minimum mode configuration. This is entire things about minimum mode configurations. So next one, is there, please just you go through it. Dear all students, I will give you 5 minute time just to go through it, this minimum mode configuration, scan it all the pages. If any doubts, please, I'm waiting your doubts. After 5 minutes again I'll go to maximum mode configuration. So very small unit, this one lecture and one more lecture more than enough to complete this unit, very small unit. Okay, so we don't go hurry up, we don't go fast, so take your own time, do well. Anything else, please let me know. Otherwise, after 5 minutes, I'll start with maximum mode. Okay, take your own time for 5 minutes. Okay, fine. Uh, if no questions, then can I move to? Okay. So okay. Maximum mode configurations also need. So it remaining only 15 minutes is remaining. So it takes again more time. So for that, what I will announce you, dear all students, just you go through this architecture. I will explain you in next lecture. This entire maximum mode configuration. So here is that maximum mode configuration. Just we are going to use one more extra chip, that is 8288 along with 8086. We used 8284 same in the previous one, and 8282 also we are using same for latch purpose, and 8286 we have to use it for again transmitter as well as receiver, and one more we are using 8288, that is bus control purpose we are using in the maximum. So because in the maximum mode configuration, more data we are going to be transferred. For that reason, the control of bus is very important. For to bus controller, we have to use one more chips, that is 8288. So dear all students, this one I am going to explain you in the next unit. So just all of you go through it. Just all of you go through it. So in the next unit, I have to cover this maximum mode configurations, as well as one more small topic, that is system bus timings. That system bus timings for read as well as write operations we have to study it in the next lecture. For read and write here, and for minimum mode and for maximum mode, read and write. This is enough. Only one more lecture is need to complete this entire unit. Very smallest. Always I am repeating. Fourth unit is very smallest one. Very less times we have to take, and remaining one more lecture is need to complete this. So remaining all the portions I have to cover you in the next lecture, because in next lecture I got 2 hours lecture. Okay, in the 2 hours lecture I have to complete it all these fourth units. You don't feel like that today only started, tomorrow only finishing, because data is very less. Only 2 topics, minimum mode and maximum mode. Only 2 topics. That's what today and tomorrow we have to complete it. So along with dear all students, this is for the today's lecture. So maximum mode configuration, I have to explain you in the next class. Please all of you just go through these notes, and minimum modes whatever I covered, that one also you have to go through it. Any doubts are arises, please ask me in the next lecture, make a questions. So this is all about your today's lecture. So and some more, one more questions, that one question is asked by one of the student, that is uh, decimal adjust addresses instructions, decimal address instructions, that repetitions they need. But I tell them you to make a schedule at 6 p.m. Today also you have to make a test, and you have to create a one Zoom link and send me. I will log in and I will explain you whatever concept you need. But that one question is still pending. I remember that, but you are not providing me Zoom link. Please, I request you who are asking that question, in the unit number third, decimal adjust instructions, all those 10 to 15 instructions I want to explain, because you may not understood. So anytime after 6 p.m. you have to send me a Zoom link, and you are tell me, I'll join and I'll explain you for that. Only one question that is pending. Okay. So I remember, please you have to do your needful things for that. And dear all student, tomorrow I have a lab session at 11 o'clock. So in the lab session at 11 o'clock, I have to conduct again 2 more programs. 2 more programs we have to practice tomorrow. It may be a second program of your syllabus. That is 32-bit addition and subtraction. All of you done with 16-bit addition and subtraction first program. So tomorrow in the lab sessions, we will go for addition and subtraction for 32 bits, and division is there, multiplication is there, that one also we have to carry in the tomorrow lab sessions. So all of you don't forget, at the 11 o'clock, please join. So last Thursday, someone late joined because of they didn't carefully saw their timetable. So now only I have to announce you. Tomorrow's Thursday timetable is different. It is only for the lab sessions. So all of you go through the lab sessions timetable and you have to act accordingly. And in the 11 o'clock, I have to take a lab sessions. And apart from my lab sessions, I have to hand over one more sessions from any other subject. So for that, I have to conduct test. Tomorrow test on first and second unit. Any of the sessions I have to conduct. And tomorrow only at morning, I will announce to you at what session we have to conduct a test. So this is for tomorrow's schedule. So please, all of you go through this and do the study very well. Uh, and also we have to within this week we have to complete this fourth unit. So once we completed fourth unit, 50% syllabus is going to be covered. So day by day, all of you have to repeat it with all the instructions, whatever we covered in the third unit. Please, all of you go through all the instructions because that is very much important for your lab sessions. So this is from my side today's lecture and today's announcement for tomorrow's lab session as well as test. Please, you have to be ready with the test tomorrow's and you have to act accordingly. So, okay, this is today. Almost, I'm going to stop my lecture. And all of, if any questions you have to ask, still 10 more minutes is there. If no questions, then you have to give me your attendance and you can log out. Okay, it's fine. Thank you all. सर जी आप नहीं नहीं मैं वो गायकवाड़ सर सब्जेक्ट
पप्पांनी खाली पहिलेच नाही पण काय जा ही बी व्हॉट्सअप का ठेवली तू बिझनेस व्हॉट्सअप काय करायचं असतं ह्याच्यामध्ये ह्याच्यामध्ये काय करायचं असते ह्यामध्ये काय लेक्चर येते फक्त लेक्चर बघायचं ह्याच्यावर